Welcome to Blue Pen Land here. Classic. This is a classic Kirchhoff's law. In fact, this one's pretty easy. I feel like. Anyway, the way I set this up was I just did. This was I1. Remember, no man is an I1. Then I guess that of course the current's going to go this way, which it must, right? I called that I2, right? And then I called this guy I3, right? And the cells have a negligible internal resistance. That means that there's no little resistors associated with these cells, that the resistors are just the resistors we see there. Okay, now if they had an internal resistance, you would just add another resistor here and do your analysis, right? Okay, so I set these up like this. Your equations are I1 plus I3 equals I2, right? Or if we're going to do them in matrix-friendly form, right, I'm going to go I1 minus I2 plus I3 is 0, right? Okay. And then if we look at our loop laws, right, I did a loop here, just a clockwise loop in this left-hand side there, right? So this is going to be this first loop here. I'll call it loop 1. Okay. That first loop, loop 1, let's see. I did what? Plus 9 minus 3I1 minus 6I2 is 0, right? And then I did another clockwise loop here. Start here, I just started clockwise, right? So that would be plus 6I2. So I'm going this way, right? Plus 2I3. And then I'm going this way through the battery, so I'm going backwards, right? Minus 12 is 0, right? So to make this matrixable, this becomes, I think it becomes 3I1 plus 6I2 plus 0 I3 equals 9. And what I did there was I put the 9 on the other side, and then we had a negative 9, and then I made everything positive, because I like to be positive. Okay, let's see. And then this guy is 0 I1, right? Plus, let's see, 6 I2. Let's see, plus 2 I3 equals 12. Let's just double check that. Is that right? Yeah. All I have to do is put the 12 on this side. It becomes positive, right? And I've got 6I2, 2I3. And then just make this into a matrix, right? Your matrix will be, 1, negative 1, 1. Our coefficients, right? 3, 6, 0, 0, 6, 2. Invert that guy and then multiply that by 0, 9, 12. Anyway, I got actually that I2 and I3 were both 1.5 amps. I got that I got I1 was 0. I got I2 and I3 both as 1.5. Okay. Anyway, there's that, right? And then it says in the next part, it says calculate the potential difference between X and Y, right? Well, for X and Y, the difference is that what we're going to do is just do an IR, right? Okay. So from X and Y, if we go from X to Y, the change in potential, right, is that we go down 6 times whatever that current is. And for us, it was I2, right? So whatever you got for I2, I think it's 1.5, right? It's 6 times that. And then the formula I'm using there is V is IR, right? So you find, and we do this on our tests too, right? So you should be able to do this. So I found that, right? Multiplied that. And then the question is state whether X or Y is at a higher potential, right? Remember that the potential drops as the current goes through a resistor, right? So X is going to be at a lower higher potential and Y will be at a lower potential, right? Because if we go this way, it drops. If we go this way, it goes up, right? The potential goes up. So X is at a higher potential than Y, okay? Make an argument for that. Talk about the direction the current flows and how voltage drops as you go through a resistor. All right, I hope that helps.